Hi, my name is Don Rainier Hamosmos, and I'm going to report about ports and harbor. Basic terms. So, ports, harbor, haven. Port structures: wharf, berth, quay, pier, jetty, dock, mole, breakwater, and dock basin. Ports and harbors conduct four important functions: administrative, ensuring that the legal, socio-political, and economic interests of the state and international maritime authorities are protected. Development. Ports are major promoters and investigators of a country's or wider regional economy. Industrial. Major industries process the goods imported or exported in a port. Commercial. Ports are international trade junction points where various modes of transport interchange, loading, discharging, transits of goods. A port is a facility for receiving ships and transferring cargo. They are usually situated at the edge of an ocean, sea, river, or lake. Ports often have cargo handling equipment such as cranes and forklifts for use in loading and unloading ships, which may be provided by private interest or public bodies. Often, canneries or other processing facilities will be located nearby. Harbor pilots or tugboats are often used to maneuver large ships in tight quarters as they approach and leave the docks. Ports, which handle international traffic, have custom facilities. The terms ports and seaports are used for ports that handle ocean-going vessels, and river port is used for facilities that handle river traffic, such as barge and other shallow draft vessels. Some ports on a lake, river, or canal have access to a sea or ocean, and are sometimes called inland ports. A fishing port is a type of port or harbor facility particularly suitable for landing and distributing fish. A dry port is a term sometimes used to describe a yard used to place containers or conventional bulk cargo, usually connected to a seaport by rail or road. A warm water port is a port where the water does not freeze in winter because they are available year-round. Warm water ports can be a great geopolitical or economic interest, with the ports of St. Petersburg and Valdez being notable examples. A port of call is an intermediate stop, for example, to collect supplies or fuel. Cargo containers allow efficient transport and distribution by eliminating loading of smaller packages at each transportation point and allow the shipping unit to be sealed for its entire journey. Standard containers can easily be loaded on a ship, train, truck, or airplane, greatly simplifying intermodal transfer. Cargo often arrives by train and truck to be consolidated at a port and loaded onto a large container ship for international transport. At the destination port, it is distributed by ground transport. A harbor is a place of security and comfort. A small bay or other sheltered part of an area of water, usually well protected against high waves and strong currents, and deep enough to provide anchorage for ships and other craft. It is also a place where port facilities are provided. Example, accommodation for ships and cargo handling facilities. The term port or seaport normally includes the harbor and the adjacent town or city as suitable for loading goods and embarking men. A haven is a type of harbor used in literature or in names in and adds the idea of refuge. Ships are accommodated and handled, loaded and unloaded at such port structures. Example, the wharves, the quays, the piers, the jetties, and sometimes alongside moles or breakwater. Any place where a ship can safely lie alongside a quay, pier, or dock, at anchor or a buoy, and where she can carry out loading and discharge operations or embark and disembark passengers is called a berth. A dry dock. A dry dock is a type of dock consisting of a rectangular basin dug into the shore of a body of water and provided with a removable enclosure wall or gate on the side towards the water, used for major repairs and overhaul of vessels. Wharf is the oldest term in English referring to port structures. It denotes any structure of timber, masonry, cement, or other material built along or at an angle to the navigable water with sufficient depth of water to accommodate vessels and receive and discharge cargo or passengers. The term can be substituted for quay when applied to great solid structures in large ports. The area between the quay wall and the nearby warehouse of storage facility is called the quay apron. This is an example of a quay or a wharf. A pier is a construction work extending into the harbor with sufficient depth of water alongside to accommodate vessels, also used as a promenade or a landing place for passengers. A jetty is a small pier, usually made of timbers, for boats, yachts, or fishing boats, but it also refers to large ships. This is an example of a jetty. The term dock has a number of meanings. It is an artificially enclosed basin into which vessels are brought for inspection and repair. A dock is a place, usually man-made area, of enclosed water where ships are loaded, unloaded, and repaired. Originally, it denotes an area of water that can accommodate a ship and can be closed off by locks to allow regulations of water level. It also means a space between two waves, wharves, or piers for the mooring of ships. Example, a dock basin. Often it can be interchanged with the terms wharf or pier. In US, it is often indicates a small landing pier for accommodating boats in a river or lake creek. This is an example of a dock. A mole or breakwater is a massive port structure made of masonry or large stone blocks laid in the sea to protect the harbor from waves and current. Sometimes the term jetty and pier are used to mean the same. Some points to consider in ports and harbor. Breakwater. W equals K times H with the exponent 3 times SR over cosine minus sine theta to the exponent 3 times SR minus 1 to the exponent 3, where W is the weight of individual cap rock in kilograms, K coefficient equal to 15 for rubble stone, S is the specific weight of cap rock in metric tons per cubic meter, H equals height of wave from tuff to crest in meters, theta angle of slope with horizontal. For fender system and dock, E equals 1/2 times W over G times V squared, where E is equal to energy in feet tons, W Displaced weight of ship in long tons. V equals velocity of ships normal to the dock in feet per second. G, acceleration due to gravity equals to 32.2 feet per second or 9.81. The energy to be absorbed with the fender system and the dock is usually one half of E. Wind. P equals 0.00256 times V squared times K, where P equals the velocity pressure in pounds per square, V velocity of wind in miles per hour, K shape factor equals 1.3. A breakwater is a structure constructed for the purpose of forming an artificial harbor with a basin so protected from the effect of waves as to provide safe berthing for fishing vessels. There are many different types of breakwater: natural rock and concrete, or a combination of the two, are the materials which form 95% or more of all breakwaters constructed. Parameters for the construction of a breakwater. When a breakwater is to be built at a certain location and the environmental impact of such a structure has already been evaluated and deemed environmentally feasible, the following parameters are required before construction can commence. First is a detailed hydrographic survey of the site. Second, a geotechnical investigation of the seabed. Third, a wave height investigation or hindcasting. Fourth, a material needs assessment. And lastly, the cross-sectional design of a structure. Geotechnical investigation. A geotechnical investigation of the seabed is required to determine the type of founding material and its extent. The results of this investigation will have a direct bearing on the type of cross-section of the breakwater. Wave hindcasting. The height of wave incident on a breakwater generally determines the size and behavior of the breakwater. It is hence of the utmost importance to obtain realistic values of the waves expected in a particular area. Behavior of water waves is one of the most intriguing of nature's phenomena. Waves manifest themselves by curved undulation of the surface of the water occurring at a periodic interval. They are generated by the action of wind moving over a water body. The stronger the wind blows, the higher the waves generated. They may vary in sizes from ripples on a pond to large ocean waves as high as 10 meters. Material needs assessment. Given that most breakwaters consist of either rock or concrete or a mixture of both, it is evident that if these primary construction materials are not available in the required volume in the vicinity of the project site, then either of the materials have to be shipped in from another sources, or by the harbor design has to be changed to allow for the removal of breakwater. Cross-sectional design of a breakwater. Last but not the least, a suitable cross-sectional design for the breakwater has to be produced, taking into consideration all of the previous data. For example, water depth. In depth water, solid vertical sides are preferred to save material. Type of foundation. If ground is soft and likely to settle, then a rubble breakwater is recommended. Height of waves. Rubble breakwaters are more suitable than solid ones in the presence of larger waves. Availability of materials. If no rock quarries are available in the vicinity of the project, then rubble breakwaters cannot be economically justified.